Good evening, everybody. So today I was looking these, mats for soldering, for working with electronics, and then I start to read about them, and then I find out that they generate static very as hell. So that's the problem with the silicone, because it's very good dielectric, but it generates a lot of static. So for me that's not good, because I have on the bench ESD mat, how you call it, like big, grounded and everything. So this is the proper thing to work on, and it's rubber based, so it's temperature resistant, but if you start to solder and work on it, it will start to look nasty very, very fast. And this I was using for about 6 years right now. It still looks good. So how I was protecting before, and I will show you some things, like 2 things, and maybe you will like it. So first thing, this is thick paper, not very thick, but yeah. The paper, if it is just, pure paper, not painted, coated, laminated, the paper never generates static. That's the first thing. Then, yeah, and you can work on it. You see, it already has burn marks and everything, but no, not on this side. And bench is protected. Now, not only is not generate static, but it works as antistatic mat if you put on the top of the antistatic mat. And I can show you. Look. So this meter can measure up to 50 megaohms, right? And of course, the bench is not conducting. ESD mat is not, is fine. You can put live circuits, the paper also. You can put live circuits, work on it, no problems. So it basically works as dielectric, but if you measure nanosiemens, right, that's for measuring gigaohms, and we measure the bench, .42 nanosiemens. So 0.42 nanosiemens, 1 divided by 0.42 is it is 2.3 gigaohms. So it has very, very high resistance to dissipate the static, and everything goes to ground. This mat actually is two layers. The bottom layer has kilo ohms, is the one type of rubber. On the top is other type of the rubber, less conductive, so you can work on it with the put live circuits and stuff. So now, if we measure the paper, right, 0.78. 0.78 also it is conductive. Whatever, we can calculate how many gigaohms, but that's not very important. But look, if I measure between the ESD mat and the paper, see, 0.5. That's so it works like proper ESD thing. And it's very nice to work on, if you take thick paper, and you can use anything. You can use even printer paper. Of course, it's comfortable when it's thick. That's with the paper. Now the other thing. Sometimes I have some you can have some very delicate circuits, which you don't want to put on the hard surface. Maybe it has some sticking, contacts or parts or something you don't want to bend, and it's not convenient to, clamp it into the vise or something like that. So you want something soft. What you can use, like this thing, this is a towel, very soft, very nice. Some things you don't want to damage, you can put and work on it, solder and everything. This is pure cotton. And the cotton is, it will not melt. You can work with the soldering iron on it like easily. What is with the cotton? Same thing. The pure cotton never generates static, ever. Just be sure that it's pure cotton. And of course, it is not conductive, right? 50 megohms, no. Is no. But if you measure in gigaohms, let's see, meter needs to calm down. Pam, 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 pam. Yep. And now we can measure them. You see? It is conductive. And if I measure between the towel and the bench, same thing. See? So the towel works as extension of the ESD mat. You can perfectly work on it. And it's very comfortable on this sort of stuff. Of course, if you're worried about ESD, you have this thing, you have, you know, this stuff. You ground it, and so I use towels and just simple, you know, hard papers just to protect my bench. And towels is comfortable for many years. And on ESD mat it works like, you know, proper ESD safe environment. So that's the tip for the day. I hope it helps somebody. And I hope we will see each other next time. Bye bye.